We are going to work on different examples now, and we will try to evaluate the logarithms. At the first glance, the logarithms that you see right here are quite complicated. The truth, though, is that the logarithms that we are working with are not that complicated if we use the properties of logarithms. So, let's try to work those together. The first step that we do is to recognize what type of logarithms we have. Right here we have two logarithms with the same base, and they are added. So if we consider the first property that says that whenever you have two logarithms with the same basis that they are added, then you can take the logarithm of their product. We can do exactly this to solve this problem. So we have two logarithms with the same base that they are added. So instead of that, I can consider the product of the two numbers inside the logarithm. So I go from the addition to the logarithm of their product. And this is going to be nothing else than the log with base 4 of 2 times 32 is 64. Now I know that the number 64 is going to be 4 to the third. So the exponent right here, where I raise the base 2, is number 3 to get the number 64. So I start with 4 to the third, and this is how I get my number 64. The exponent is nothing else than your logarithm. So the logarithm of 4 with base of 4 to the third with base 4 is equal to 3. Let's look at the second example. I have the log of 100 with base 5 and the log of 4 with base 5. Now in this case, the property that helps me is the second one. As you can see, if you have two logarithms with the same base and you subtract the one from the other, then this is going to be equal to the logarithm of their quotient. So I can rewrite this expression as one logarithm of the quotient of 100 over 4. And this 100 over 4 is nothing else than 25. So this is log of 25 with base 5. Now I can observe that 25 is nothing else than the perfect square of 5. So I can write it like that, and I have log of 5 squared with base 5. The corresponding exponent that I have right here is the number 2. So this is going to be nothing else than the result of my logarithm. This is the actual logarithm. So this is going to be equal to 2. And that's my answer. Let's look at the last example. We can see right here that I have a logarithm with base 6 of 9 multiplied by a constant, 1/2. What I have is the property that helps me, the third property, that is the power rule. Whenever I have a constant multiplied by a logarithm, then I can assume that this is equal to the logarithm with the same base of x, the number that is inside the logarithm, inside the argument, to the number that, to the constant that is multiplied by the logarithm. So instead of having now 1/2 times log with base 6 of 9, I can write down that this is nothing else than the log with base 6 of 9 to the 1/2. And this is added to the log with base 6 of 2. Now, the first thing that I need to remember is that whenever I have rational exponents, 1/2 right here, this can be replaced by a radical. Since 2 is the denominator of the exponent, this means that the radical that I use is of order 2, meaning I have a square root. So this is nothing else than the square root of 9. Plus, I don't touch the second part of my expression, I leave it as is. Now square root of 9, obviously, we all know that is equal to 3. So this is replaced by the log with base 6 of 3 plus the log with base 6 of 2. What I want you to see now is that except of using the third property right here, at this point I can also use the property 1. Why? Because now I have a sum of logarithms with the same base 6. Right here, 2 logarithms with the same base. Since I add those 2 logarithms, this means that I can replace that with the logarithm of their product. Log with base 6 of 3 times 2. Okay? And this is nothing else than log with base 6 of what? Of the number 6. Now, can I remind you that we have 2 more properties that we always need to remember? The log of a with base a is equal to 1. The log of 1 with a base a, any a, is equal to 0. So these are the 2 other properties that you need to memorize. And this is equal to nothing else than 1. Why? Because I'm taking the log with base 6 of 6. And this applies to this property right here. The logarithm of any number with the same base is equal to 1. Now, why is that? If you look at this closer, you will see that this is nothing else than 6 to the first, right? So I wrote it as a power. The exponent for that is 1. So since it's 1, this is going to be my answer. Okay, so basically we just look at this in 2 different ways. The answer, of course, is going to be the same, equal to 1.